Good morning, guys. Now, before we begin today's class, I want to let you know that for some reason, students are having a hard time with the difficult process of typing here in the attendance form. Now, due to the fact that it is so extremely complicated to access a link and just type here, and to make your life easier, I'm just going to exclude from now on the attendance form. Your notebook will be your attendance, or not the notebook, the homework. So make sure you upload the homework daily. Now, one thing to keep in mind, I am heavily weighting every single homework. If you miss a single homework, I'm gonna drop you 10 or 15 points off your notebook for a single one. So throughout the period that you are at home, if you miss 3 homeworks, that's pretty much a 50 or less in your notebook. I am giving this a lot of importance. So make sure you work properly and you do your daily homeworks before 10. If you're having trouble with the internet or your cell phones, don't write to me at 10:15 p.m. That means you lost your points. You write to me at 9. Profe, tengo problema. Do not leave this for the end of the day. Again, I'm giving you a free schedule for you to work whenever you want. But if you don't want to be crying later, profe, but I was a minute late. Make sure you turn it in on time. You turn it in at 10:01, it's late, you lose the points. I'm giving you the freedom to work whenever you want to work. If you choose to work late, you must assume the consequences of possibly turning in your homework late. Again, you guys are grown-ups, so no more attendance because apparently it was too difficult for many of you. Let's just go ahead and upload the homework. Now, homework again will be your attendance from now on. So it's doubly important you upload your homework. Because again, if you don't upload the homework, that means you didn't even watch the video. Make sure you send your homework every day. Today we're going to go over augmented matrices. Yesterday we went over Gaussian elimination. And as you can see, we have a whole bunch of letters and systems, and it was, quite difficult. Not difficult, just messy. Messy, didn't look very organized, a whole bunch of letters and signs. Now, today we're gonna go over what an augmented matrix is. We use augmented matrices to represent linear equation systems, and it allows us to work in a faster, cleaner, elegant, just more efficient way, even though it's almost the exact same thing. Imagínense, if I tell you, okay, let's go ahead and solve this linear equation system. Honestly, just looking at this, it's giving me a headache. Here I have y's, x's, z's, I'm missing, or w's, x's, z's, I'm missing my y. Here I have an x, y, z, but I'm missing my w. Here I have a w, y, z, but I'm missing my x. Here I have a w, x, y, I'm missing a z. It's a nightmare. And I would never work on this linear equation system if I did not turn it into an augmented matrix. Makes your life way easier. Now, an augmented matrix is just like a regular matrix, a set of numbers, a group of columns and rows that has elements which represent usually numbers. Now, in order to turn this linear equation system into an augmented matrix, I'm going to use my keys to represent a matrix. Now I'm going to ask myself, how many variables do I have? I have w, x, y, z. Even though not all the equations have all the variables, doesn't matter. You're going to see total how many variables your system has. It has 4 variables, w, x, y, z, and the constant row. That 4 variables and the constant row, or the other side of the equation. That means your augmented matrix must have 5 rows. Now we're going to use a dotted line to represent the equal sign. And I'm just going to plug in the numbers. 2, 0, -1, 9. And in order to turn the linear equation system into an augmented matrix, it's pretty much like synthetic division. We're just going to focus on the leading coefficients, or not the leading coefficients, the coefficients of all the terms. Now let's have, Even though you don't have to put it up here, just so you can visualize it, let's have this column represent the W's. This column represent my X's. This column represents my Y's. This column represents my Z's. Not necessary to do this, but if it's gonna help you just, remember, be more organized, that's fine. Now, I have a 1 here. I have a 4 here. I have a 0, and I have a 1. I have a W0, no zeros, X1, Y2, Z -3, W is 1, X is 0, Y is -3, Z is -8, W is 3, X is 2, Y is 3, and this is 0. Now you're gonna say, Profe, okay, what the heck is the point of this? Again, now you can just start eliminating, or using Gaussian elimination. If I multiply this by -1 and add it here, I get rid of this variable. If I multiply this by -3 and add it here, I get rid of this variable. Again, I'm gonna do a couple of examples right now so you can see how it works, but the whole point is, it's way easier to visualize. You don't have to write out your X's and your Y's, and then you say, well, no, here, I know I'm missing a W. Here, I know I'm missing a Z. And you'll see how much easier this is gonna make your life. Now that you know how to write an augmented matrix, let's go over a particular linear equation system. Now, let's go over on page 367. I'm gonna write the linear equation system that they gave us at the top. And in this case, it's somewhat easy because, it's only 3 lines or 3 equations, and they all have the variables, etc., etc. But trust me, you're going to be given very big linear equation systems, and if you don't use augmented matrices, you're going to end up with a headache. Believe me. Step 1, let's turn this into an augmented matrix. I have 3 variables and a constant line, so I'm going to need 4 columns. Let's begin with my X's. 1, -1, 3. Now let's go with my Y's. -1, 2, -2. Let's go over my Z's. -1, -3. There we go. And 7. And now my equalities, or my answers at the end. -12 and 30. Okay, now one thing to keep in mind. When you're turning your linear equation system into an augmented matrix, make sure that's why I double checked. You have to double check the numbers and the signs. A single sign that you copy incorrectly will throw off your entire system. Okay, you have to be very careful. And you'll see later, these systems might have one solution, multiple solutions, or infinite solutions. So at the end, you might think you did it correctly. You end up with infinite solutions, but it might be one solution, or vice versa. So just be extra careful when you're copying it from a linear equation system to an augmented matrix. And again, remember, this represents my X, this is my Y, and this is my Z. Now also, when you're doing the line operations, multiplying, adding, subtracting, dividing, when you multiply and change the sign, make sure you be very careful. And remember, if you change the sign, the entire row, you have to do a sign change, even the 30. So if I change this row signs, -3, +2, -7, -30. Now, we're gonna do the exact same process we did yesterday, only instead of using a whole bunch of numbers with variables, just a very nice and elegant matrix. That's it. So what I'm gonna do is, since I'm working on a whiteboard, I'm gonna do my operations on this side and then copy the answers onto my matrix. When you're working on a test or at home, I do not recommend you erase and write the answer again. What I recommend is that you just write the matrix again. Even though it seems like a lot of writing, it's gonna help you keep organized, and that's very important. Now again, remember yesterday when we talked about Gaussian elimination, We wanted to eliminate all the way down to a single variable, and then from that one variable, I worked my way up. When we're talking, about a matrix, that means I have to get rid of two of these x's. So let's see. If I were to add, let's put the numbers of the rows. If I were to add row 1 to row 2, I would get rid of this x. So let's go ahead and do that. 1 minus 1 is 0. Negative 1 plus 2 is 1. Negative 1 minus 3 is negative 4. 7 minus 12 is negative 5. So I'm going to substitute the second row for this value, which is the result of adding these two lines. Okay, just combining these two. Let me confirm. 0, 1, negative 4. Always double check, because believe me, you don't want to have a mathematical issue with these systems, because it's a pain in the butt. So mission accomplished with my second row. I got rid of the first variable. Now let's get rid of this variable. Also, you want to end up with a 1. The first element should be a 1. It's going to make your life easier. And you'll see why later it's important. Now here, let's get rid of this element. How do I get rid of this element? I multiply the first line by negative 3 and then add it to this one. So when I multiply the first line by negative 3, I'm going to end up 1 times negative 3 is negative 3. Negative 1 times negative 3 is positive 3. Negative 1 times negative 3 is positive 3. And 7 times negative 3 is negative 21. Let's confirm. Correct. That was just the multiplication of this line by negative 3. Now I'm going to add the multiplication of row 1 times negative 3 plus this row to get rid of this 3. 3 minus 2, 7, 30. When I add them, I'm going to get 0, 1, 10, 9. So that becomes my new bottom row. 0, 1, 10, 9. Now, as you can see, my x's, I only have this one x. Perfect. I'm done with my x's. Now let's look at the following line. I gotta get rid of this. So how do I get rid of this? Easily. All you gotta do is multiply this times negative 1 and add here, or this times negative 1 and add here. You're pretty much gonna end up with the exact same result. What I recommend is that you always manipulate the line above to match what you gotta get rid of below. But you don't have to do it that way. So in this case, I multiply this by negative 1 and this by negative 3 to get rid. Here, I'm gonna multiply the middle row times negative 1 and then add it here to get rid of this one. So when I multiply the second row by negative 1, I end up with negative 1 plus 4 plus 5, all these numbers times negative 1. Then I'm going to add it to this row. 1, 10, 9. I end up with 0, 14, 14. So I'm going to change this row to 0, 0, 14, 14. Now, since you want your first numbers to always be 1, I'm going to divide this entire row by 14, because you can do it. It's an equality. It's an equality. I can divide this side by 14, this side by 14, and I end up with 1 equals 1. And now you know that your z value is 1. Your y value is, y minus 4z equals negative 5. So you can start substituting, and that would be your answer. Pretty much when you have this is called the row echelon form. The first term is always, the first non-zero term is always a 1. The first non-zero row is a non-zero element on the row is always a 1. And also, Below the number ones, you always have zeros. Those are row echelon forms. When you reach that configuration, pretty much that's your answer. You can start substituting backwards and you're done. Okay. Now, let's look at example 3. Example 3 in the book, it says at page 367, identify an augmented matrix in row echelon form. That's what we want to end up with. So let's look at A. A looks like this. 1, 0, 2, 1, 0, 4, negative 1, 2. First non-zero element is a 1. First non-zero element is a 1. Everything below my 1 is a 0. It is in row echelon form. Follows the rules. Again, first non-zero element is a 1. All the numbers below 1s are 0. Perfect. Let's look at example B. It is a little bit bigger. Let's look at example B. I have 1, 6, 2, negative 11, 10. I have 0, 1, negative 5, 8, negative 7. I have 0, 0, 0, 0, 1, 14, 0, 0, 0, 0, 0. First non-zero element is 1. First non-zero element is 1. First non-zero element is 1. There are no elements. It's all zeros, so that's good. Under my 1, I have all zeros. Under my 1, I have all zeros. Under my 1, I have all zeros. Perfect. Row echelon form. Let's look at the last example. 1, 0, 0, 5, negative 6, 10, 1, 9, negative 3, 1, 0, 14. First non-zero element 1, first non-zero element 1, first non-zero element 1. Great. All the numbers below this one are 0. Here, this is a non-zero number under a 1. It is not in row echelon form. No. You have to multiply this by negative 1, add it here, and then you'd have row echelon form. Once you get rid of that 1 that's under this one. All numbers below my 1s have to be 0. So that's it. So for today's homework, I want you guys to do the exercises 22 through 29. Actually, 22 to 27. Do numbers 22 to 27. You're given linear equation systems. Turn that into augmented matrices. Turn that matrix into row echelon form. Find the solutions. If you have any questions, let me know. Remember, homework is attendance from now on. Have a great day.